नाउ एलिमिनेशन रिएक्शंस। आज का जो हमारा टॉपिक है वो है 12th क्लास केमिस्ट्री में एलिमिनेशन रिएक्शंस। तो पहले हम बताएंगे एलिमिनेशन रिएक्शंस क्या है। ये जो है तीसरी कैटेगरी है, इनकी तीसरी कैटेगरी जो केमिकल प्रॉपर्टीज है, केमिकल रिएक्शंस में अल्काइल हैलाइड्स पढ़ रहे हैं, उसमें ये तीसरी कैटेगरी है। तो एलिमिनेशन रिएक्शंस क्या है? एलिमिनेशन रिएक्शन, दीज आर दोज रिएक्शंस in which two or more than two atoms or groups are eliminated or eliminated from an alkyl halide form alkenes. One common example is de-hydro-halogenation of alkyl halides. See, we have already discussed the nucleophilic substitution reactions of alkyl halides. That is, say any alkyl halide CH3CH2 X, where this X is any halide. ये कोई भी हैलाइड हो सकता है, क्लोरीन, ब्रोमीन, आयोडीन में से जो ये हैलाइड होता है, इसमें क्या होता है? अल्काइल हैलाइड में कोई भी ग्रुप से दिस X either through substitutes this X by this Y, and we will get a product CH3CH2Y plus X negative. At that time, this is simply a substitution reaction, a nucleophilic substitution reaction. But however, if this group, the incoming group Y, instead of substituting this X, it will attack to this CH3 and remove a proton from this, then it's not in substitution. This is simply elimination reaction. So what we will get at that time, we will get simply CH2 plus HX. So in this case we have alkene. Well, in this case we have substituted product. This reaction, that substitution reaction, we have already discussed these in SN1 or SN2 mechanism. But today our topic is simply the elimination reaction, in which two or more than two groups. See, X and then a hydrogen atom. Usually X comes from the functional carbon, that is an alpha carbon, and a hydrogen from carbon number 2, or that's known as beta carbon, are eliminated to form a product, that is alkene. So we will discuss these elimination reactions. Since in case of elimination reactions, in case of these elimination reactions, we have two types of mechanisms. One is E2, or this is simply known as E2, or this is known as bimolecular elimination reactions. The second one is E1 or unimolecular elimination reaction. So that means these elimination reactions will follow either E2 or E1. Let's discuss first one, that's E2 elimination reactions or bimolecular elimination reactions. Now, bimolecular elimination, or simply we'll call it E2 elimination, E2 reactions, that is bimolecular elimination reactions. Bimolecular elimination reactions. Now, bimolecular elimination reactions, these are those reactions in which the rate of a reaction depends on the two reactants, that is the reaction or the rate of reaction depends on the both alkyl halide as well as base. Those reactions, bimolecular or E2 elimination reaction, these are those reactions in which the rate of a reaction is determined, or the rate of a reaction is determined by both, that is alkyl halide as well as by the base. So both these alkyl halide and base are involved in the rate determining step of reaction, usually the lowest step. Now, bimolecular reactions are actually concerted single step reactions. That means they will occur in a single step. Let's take an example of ethyl bromide. Say this CH3 CH2 Br in presence of a base OH, alcoholic OH. This will give us, since it will remove hydrogen from the beta carbon, if it is carbon number first order functional carbon, so this is alpha, or carbon number 1, this is beta carbon. Usually the OH removes the proton from beta carbon and forms water plus alkene. So we will get CH2 plus, we will get HBr here, water. So this is the general reaction of E2 elimination reaction. HBr, sometimes we have, sometimes not, it's water also there. HBr or water. If OH removes the proton here, then we will get water and Br negative. But this Br will also react with the H positive and we will get HBr, or usually we have alcoholic KOH. That means we will have KBr, not HBr. So we will get KBr and H2. Now the mechanism of this reaction. Mechanism, actually the stepwise mechanism of E2 elimination. Mechanism of E2 elimination reaction. Mechanism is simply the stepwise formation of a product from the reactant, that's known as mechanism. Now the first step of this reaction is, first step, what actually happens, say we have this ethyl bromide, that is CH2 hydrogen, CH2 Br, in presence of a base OH. What actually happens in case of this E2, this is usually a slowest step and rate determining step. That means both these are involved in this rate determining step. Slowest step is actually the rate determining step of these E2 reactions. What actually happens, this base actually attacks the beta hydrogen of alkyl halides, this is alpha beta. What actually happens, this base attacks to this proton and we will get an intermediate like this. So we'll get an intermediate like this. When it base attacks to this, we'll get, this is OH hydrogen, and there is actually a partial breaking of this bond. We have hydrogen and hydrogen is there, then this CH2 Br. What actually happens, so when this base attacks to the hydrogen, beta hydrogen, there is actually what happens, this bond starts to shift or migrate its electron pair towards this carbon, and because of the shift of this electron pair of the hydrogen, the electron pair between the carbon and bromine also starts to move or shift towards Br. That means it will also starts to shift towards Br. Because of this will form a transition state, or this will form a transition state, which is actually in a state in between the reactants and products. What actually happens in this case, that means the bond between the carbon and beta hydrogen is not completely broken or shifted towards this, and the bond between the carbon and Br is also not completely broken. In other words, this bond, that is the carbon double bond, is not completely formed as well. So this is in an intermediate state in which all the bonds which are undergoing the shifts, they are in an intermediate state. Now what happens then, this bond completely migrates to here and it will form a double bond, and this electron pair will shift towards Br, and Br will come out as Br negative, and we will have a double bond here. So we will get C double bond CH2 double bond CH2 plus we will have H2O. So we will get alkenes. But this is in a concerted single step reaction. Only what is there? There is an intermediate between the reactants and products, not an intermediate. This is actually in a transition state between the reactants and products. So that means this is formed when a transition state. Product is alkene. Now we will take some examples in which we have more than one beta hydrogen, not only this single. Let's take an example, say, in which we have more than 2 beta hydrogens. Say this one. If we will take the example of this 2-bromobutane, CH2 2-bromobutane. let's have this one. So if in presence of base, it will follow E2 mechanism. Then we have two types of beta hydrogen. We have these two hydrogens are beta hydrogens, and these three are also beta hydrogens. So OH have two options. Either it will remove this hydrogen from CH2, or it will remove a hydrogen atom from this CH3. Now the question is, we will get to, if OH removes this hydrogen, we will get one product, or if it removes this hydrogen, then we will get next product. So that means we will get two products. तो इसमें क्या होगा, हमें दो प्रोडक्ट्स बनेंगे. अब जो दो प्रोडक्ट्स हम देखेंगे, लेट अस सी द फर्स्ट वन. अब हम पहला जो है ये वाला हाइड्रोजन अगर यहां से निकलेगा तो Br यहां से आ जाएगा, जो डबल बॉन्ड बनेगा यहां की इलेक्ट्रॉन पेयर यहां जाएगी और Br ये इलेक्ट्रॉन पेयर ले जाएगा, तो इसका मतलब है यहां पर डबल बॉन्ड आ जाएगा. सो वी विल गेट CH3 CH डबल बॉन्ड CH and CH3. So plus we will have H2O and Br negative. So what actually happens, if we will see here, the double bond is at the carbon number 2. In the first case, if this OH removes hydrogen from here, then the double bond is at the center or at the carbon number 2. Now let's have a second route. Look at this second route. If this OH removes this proton, what will happen? And hydrogen will be removed from here. Electron pair will come here and Br will be eliminated. So we will get a double bond between these two carbons. This is CH2 double bond, CH2 single bond, CH2 CH3. So what is the difference between the two? In this case, the double bond is present between these two carbon atoms or at the center, while in this case it's present at the carbon number first or at a terminal position. Now the question is, which one is the product? Which one is the product? So the product formed, is usually governed by or determined by a rule that is known as Seytzeffs rule, or this is also known as Zaitsev's rule. Seytzeffs or Zaitsev's rule. This is simply a shortcut to predict the product in case of these elimination reactions in which we have more than one product, or we have more than one product is formed. At that time, this rule, that is Seytzeffs or Zaitsev's rule, determines the major product. So according to this Seytzeffs or Zaitsev's rule, the major product in these types of reactions in which the beta hydrogen is removed usually from the carbon which contains the least number of hydrogen atoms, or in other words, the alkene which is more substituted, or in other words, the alkene formed depends on the number of the alkyl substituents. These alkyl substituents attached to the alkyl substituent attached or bonded to these sp2 carbons. That means greater the number of these alkyl groups, or in this case methyl groups attached to this carbon or sp2 carbon or carbons, more will be the stability of the alkene and it is more easily formed. So more the number of these alkyl groups attached to this sp2 carbon atom, more easily it is formed. So this is according to Seytzeffs rule. So with the help of this Seytzeffs rule, the product is formed is this one. That is, first will be the major product, while as this one it will be the minor product according to Seytzeffs rule. According to Seytzeffs, that means greater the number of methyl groups or the alkyl groups, the more stable the alkene, the more easily it is formed. This is simply the statement of Seytzeffs rule. That means greater the number of alkyl or methyl, in this case alkyl groups attached to sp2 carbons, greater the number of alkyl groups attached to the sp2 carbon atoms, comma, the more stable the alkene formed is, and more easily it is formed. It's simply the statement of this Seytzeffs rule, or in other words, the more substituted alkene is only possible when the beta hydrogen, when this beta hydrogen comes from the carbon atom which contains the least number of hydrogen atoms, from a beta carbon which contains the least number of hydrogen. That means the beta hydrogen is removed from the carbon atom which contains the least number of hydrogen atoms. So this is simply the statement of, or other statement of, or second statement of Seytzeffs rule. So that means on the basis of Seytzeffs or Zaitsev's rule, the more substituted alkene is actually the major product because it is formed more easily and is more stable. So that is why the first one is the major product in this case, the second one is the minor product, or the first one we will call it as Seytzeffs product in this case. Now the E2 reactions, elimination reactions. Coming back to this mechanism, is in case of an elimination reactions, we have both the reactant, that is an alkyl halide, and base or involved in the rate determining step. So the rate law will become rate of this reaction, or rate law for this reaction is simply rate will be equal to alkyl halide and base. So in this case, what actually happen, if we will double the concentration of alkyl halide, the rate of reaction will also double. If we will double the concentration of both alkyl halide and the base, the reaction will become 4 times. That means it depends on both, that is on the base as well as on the alkyl halide. Now the next important point is reactivity of alkyl halides. Reactivity of alkyl halides in case of E2 elimination. Since coming back to the Seytzeffs rule, that means Seytzeffs rule, the more substituted alkene formed usually is the more stable product and is formed more easily. That means the more stable alkene will be formed from a tertiary alkyl halide instead of a secondary alkyl halide. If we will take the examples of tertiary, this is tertiary. Now the second one is if we will have secondary, that is CH3, this is secondary, now primary, this is primary, secondary, tertiary. अब हम देखेंगे कि कौन इसमें ज्यादा रिएक्टिव है. सो अगर हम इसमें से देखेंगे, क्योंकि मोर सब्स्टिट्यूटेड अल्कीन इज मोर स्टेबल एंड इज फॉर्म्ड मोर इजीली, तो अगर हम पहले में देखेंगे तो यहां पर डबल बॉन्ड आ जाएगा, इसमें कोई अल्काइल ग्रुप अटैच लेफ्ट या राइट साइड में कोई नहीं होगा. इसके बरक्स अगर इसमें देखेंगे, अगर यहां पर एक हाइड्रोजन यहां से बीटा हाइड्रोजन निकलेगा और यहां से Br निकलेगा, तो एक CH3 या अल्काइल ग्रुप अटैच होगा. तो ये इसके बरक्स अगर हम इसमें देखेंगे, यहां से Br आ जाएगा और यहां से अगर एक बीटा हाइड्रोजन निकलेगा, लेकिन इस कार्बन पर जो है दो अल्काइल ग्रुप्स या मिथाइल ग्रुप्स अटैच होंगे. दैट मीन्स दिस वन इज मोर सब्स्टिट्यूटेड एज कंपेयर टू दिस टर्शियरी, एज कंपेयर टू दिस सेकेंडरी, which in turn is more substituted than primary. So that means a more stable alkene will be formed from the tertiary, followed by secondary, and then 1 degree. That means the order of reactivity is tertiary, followed by secondary, then primary. So from the primary we will get more substituted alkene, while is in case of from the tertiary alkyl halide we will get a more substituted alkene, while as in case of this primary we will get less substituted alkene. इसका मतलब है कि जो टर्शियरी है वो ज्यादा जल्दी अल्कीन बनाएगा और यही ज्यादा रिएक्टिव होगा instead of this primary. So that's what we have in this E2 reactions. Thank you.